Now let us do the question 1c, x plus 2 to the n over n 3 to the n plus 1. X plus 2 to the n over n3 to the n plus 1. Okay. Now, the same things. If we use the ratio test, it would be the limit when n goes to infinity of an plus 1 over an. It will be the limit when n goes to infinity of this guy. It will be x plus 2 to the n plus 1 over n plus 1 times 3 to the n plus 2 divided by this guy, or multiplying with reciprocal of this, divided by x plus 2 to the n here. Okay, so therefore the limit of this becomes, we cancel the like term. If you don't know how to do this, write it explicitly into slowly and rearrange the like term so that you can observe better. X plus 2 to the n cancel each other. It will be x plus 2 here. And we just write it here. 3 to the n plus 1 cancel with 3 to the n plus 1 in the denominator. Leave us 3. And in the denominator, there is the term n plus 1 right here. Okay, that's it. So when n go to infinity, so let us divide both numerator and denominator by n, right? It will be 3 times 1 plus 1 over n here. In other words, this limit becomes x plus 2 divided by 3. So, case study. If x plus 2 divided by 3 here, strictly smaller than 1, then the series is convergent. We can say that it is absolutely convergent. Or see that x plus 2, we multiply both sides by 3, it will be smaller than 3. So the radius of convergence is r is equal to 3, right? From this, it implies that x plus 2 smaller than 3 and larger than negative 3. If we subtract 2, so the center becomes x, and this here subtract 2. Therefore, it will be negative 5 smaller than x here, smaller than 1. Okay? We can show it in the lines here. Negative 5, negative 1, right? And here, it is -2. Okay, we see that by looking at this guy, we can easily see that the radius of convergence here is r is equal to 3. Okay, that is the meaning of the radius of convergence. So three. Okay. Case 2 is easy. If, okay, by looking at this guy, we can conclude easily x in -infinity, -5, union with -1 and infinity here, then the series is divergent. Case 3, if x is right here at the point -5, right, the series becomes, what is it? This guy will replace the value of x by -5, right? -5 plus 2 to the n, and 3 to the n plus 1 here. And it is easy to see that this is also the series -3 to the n, right? Here, and 3 to the n plus 1, okay? So this guy, -3 to the n, we can write it as -1 to the n times 3 to the n. And the denominator comes 3 to the n times 3 here. So we can cancel the like term right here. Right, it becomes easy. It becomes -1 to the n over, what is it? 3n. Okay. It is easy to see that this is an alternating series where the limit of 1 over 3n will be 0, and it is decreasing. It is easy to see that this series okay. Now let us move on to the case 4. When x is equal to -1, okay, it becomes, what is it? -1 plus 2 to the n here, and n 3 to the n plus 1, okay, which is 1 to the n divided by n 3 to the n plus 1, okay? n is equal to 1 to infinity. 1 to the n is simply 1. Okay, what can we say about this series? We see that in the denominator, we have this term, and then we can divide it by n, right? The denominator has another n right here. So that is why we consider this series. One over 3 to the n plus 1. Then we compare this series and the new series right here. We see that one over n times the fraction 1 over n, 3 to the n plus 1 right here. It's always smaller than 1 over 3 to the n plus 1 for any number n in the integer set, right? And is positive. Therefore, the series 1 over n times 3 to the n plus 1 here smaller than the series 1 over 3 to the n plus 1. Okay? This guy, however, the series 1 over 3 to the n plus 1 here is a geometric series. With the radius r is equal to 1/3. So it is convergent. The bigger series is convergent. It converges to a number, right, which is smaller than infinity. Therefore, the smallest series is also convergent. Okay, now let us summarize. So when it is convergent from -5 to -1, right? At -5, it is convergent. At -1, it is also convergent. So in summaries, when x is between -5, -1, and is divergent when x belongs to negative infinity, negative 5, union with negative 1 to infinity. The radius of convergence is r is equal to, what is it? 5, right? 3. Does it?